Making solution is an essential procedure involving individual or biological and chemical experiments performed across the globe.
Here are some steps for preparing solutions. Step 1. Check preparation requirements. Refer to a laboratory reference manual for any specific instruction on preparation and the bottle label for any specific precautions in handling the chemical.
Step 2. Choose a method for preparing solution with a specific concentration of solutes. Dissolving solid solutes in the solvent. Diluting an existing stock solution using the parallel dissolution technique. Diluting an existing stock solution using the serial dilution technique.
Dissolving solid solids in the solvent. To make a solution in this way, you must know how much of the solid to use and how much of the solvent to mix with it. Use the following formula to calculate the weight of the solid needed.
Diluting an existing stock solution using the parallel dilution technique. When preparing solution, if you want to prepare several solutions to have a different concentration, it is often easier to dilute an existing stock solution. One way to dilute an stock solution is by using the parallel technique. Use the following formula to calculate the amount of stock solution needed for each dissolution.
Diluting an existing stock solution using the serial dilution technique.
Step 3. Calculate the amount of reagents you need to use. Step 4. Choose an appropriate container to place the reagent. The following n steps are according to the method you have chosen. When using the first method, weigh out the desired amount of reagents. Then place the chemical into the container, and less than the required amount of distilled water. On the second and third method, you need to measure this volume here to prevent extra dissolution or contamination. Pre-rising the pipette with the stock solution to remove any water droplets or impurities. Caution: this procedure is reserved if the addition of the concentrated solution to solvent causes an exothermic reaction. Step 6. The various methods of sterilization are physical method, which includes thermal heat method, radiation method, filtration method, and chemical method like the gaseous method.
Different solutions were made which are going to be used during the semester. A 50 ml sodium hydroxide 5 molarity solution was made from molarity formula with clear number of moles and then replaced with known data and calculate. Later from number of moles formula with clear mass and then replaced with known data and calculate. 10 grams of sodium hydroxide is the mass to be weighted. A 10 ml of TEE buffer with the following indications in parentheses was made to prepare trace hydrochloric acid 10 millimolarity, clear from the next formula volume 2 and replaced with known data. Volume 2 corresponds to the amount of solution taken from the stock trace 1 molarity solution. Do the same for EDTA from a stock solution of 0.5 molarity. A 12 ml of STE buffer with the following indications in parentheses was made. To prepare trace hydrochloric acid 50 millimolarity, follow steps from previous solution, same for EDTA. Now from sucrose, if in 100 milliliters are contained 8 grams of sucrose, then how much is contained in 12 milliliters of water? We cross-multiply 12 milliliters by 8 grams and divide by 100 milliliters to obtain 0.96 grams of sucrose to be weighted. Making solutions for use in biological experiments, controlling the concentration of solids in the solution is often critical. For example, failure to carefully control the concentration of solids in solutions used to culture cells can cause the cells die or develop abnormally. Likewise, inappropriate concentration of solids in solutions that contain biomolecules may cause the biomolecules to denature or aggregate, thus making them inactive. Concentrations of solids can also affect the speed and size of chemical reactions that take place within a solution. Depending on the molecular interactions and the state of matter is the type of concentration used to prepare solutions. For example, it wouldn't be convenient to weight ethanol if you want an aqueous solution of ethanol. In the particular case of molarity, it is often used for protein and DNA concentration as well as buffers and other solutions. And finally, normality results more convenient to prepare strong acid solutions.
Preparing laboratory solutions play an important role in the correctness of an experiment. If the composition of reagent is not correct, it is often leads to errors in the observational results. While preparing the solution in a laboratory, correct proportion of chemical and solvents as well as produce is crucial. Safety is also very important in laboratories are highly prone to accidents. While using chemical react, one should be aware of correct handling, procedure, strength, and safety hazards.